Hello, I'm Dr. Catherine Zeman, at the University of Northern Iowa. This talk focuses on stressing the importance of fluorovirgin issues related to anthropogenic nitrogen loading to water and its subsequent impacts for human health and sustainability. First, the Haber versus nitrogen cycle. Currently, human activity has matched and exceeded the natural fixing of nitrogen gas into water-soluble forms, 210 million tons of anthropogenically fixed nitrogen versus 203 million tons of naturally fixed nitrogen per year, a 50% increase over the natural nitrogen fixation. In comparison, the increase in carbon loading to the atmosphere versus carbon dioxide input is estimated to be about a 10% increase. 80% of this is used in agricultural applications. Shana and colleagues, researchers from Princeton and Stanford, in 2017 Science article noted that changes in precipitation due to climate change are likely to increase nitrogen loading by 15 to 19% and will necessitate a subsequent decrease in nitrogen inputs of 24 to 33% just to offset and maintain the already high nitrogen loading rates. Also, soluble forms of nitrogen contribute to nitrogen gases that add to acid precipitation in various forms, and nitrous oxides act as heat trapping gases, 300 times more effective than carbon dioxide. Secondly is the body of concern. 29 studies since the late 1980s, indicate a variety of concerns from arthritis to cancer to thyroid problems from exposures to nitrate in the range of 0 to 10 parts per million. The author reviewed these studies and 66% of them were in this range. Furthermore, the studies predominantly were case control and cohort studies, which are significantly stronger studies than the correlational or ecological studies from the 1970s. Additionally, I'd like to bring your attention to the issue of absorption, distribution, metabolism, and excretion, taking a look at the nitrogen cycle in the body. When you look at the nitrogen cycle relative to its absorption, distribution, and excretion in the body, it's clear that the body works to maintain low levels of nitrogen in plasma, amniotic fluid, and cerebral spinal fluid. Breast milk and other forms of excretion have somewhat higher levels, all the way up to really high levels of 60 parts per million in the urine. So very clear that the body's volume of distribution in internal compartments is quite low. It's interesting to note that the natural background level of nitrate in water is 0 to 2 parts per million for waters that are not disturbed by modern agricultural practices. Now, further, the author's work in publication has found persistent elevations of pro-inflammatory cytokines markers from mononuclear cells and signs of transduction pathway stress and single-strand DNA damage when those cells are exposed to sodium nitrite at levels comparable to the range of 0 to 10 parts per million nitrate nitrogen. Finally, I'd like to talk about regulations and responsibility. The current MCL is 10 parts per million nitrate nitrogen that was set in 1974. That current MCL is an acute exposure MCL designed for infants and children to prevent chemically induced anemia called infantile methemoglobinemia. It was not established to deal with chronic exposures. I would also like to encourage the audience to consider your nitrogen footprint. If you go to the website that you see at the bottom of the right-hand corner of the slide, you can visit the personal nitrogen footprint website. See that the average citizen in the United States has about a 39 kilogram of nitrogen per year footprint, largely related to dietary choices, particularly meat eating and the use of internal combustion engines. Finally, these multitude of issues should be considered when thinking about chronic nitrate exposure, particularly through the drinking water route. I would like to thank the National Council for Science and the Environment for allowing me to do this flash talk. And I look forward to discussing this with viewers during my live session time slot. Thank you.